So activation function transforms the summed weight input of the activation of node or output. They play a rather important role in propagating the gradient into the network. So activation functions model the behavior of nonlinear aspects within the neural networks. Now, sigmoidal functions, which is a standard logistic function, is also most widely used activation function, for example, in autoencoders. Another sigmoid function, which you have hyperbolic tangents or tanh, is symmetric over its origin. It generates steeper gradients and it should be preferred over other activation functions, especially when you're using in RNNs and LSTM. ReLU is another activation function that is super popular in deep learning. And a ReLU activation function actually outputs 0 for negative values. It may hamper the performance of your autoencoders by degrading the reconstruction process while decoding. In scaled exponential linear units of CellU, so there are a whole lot of sort of LU and ReLU families, and they're rather robust when activation functions and employ strong regularization. It addresses the issues of vanishing gradients and exploding gradients, and activation functions, binary functions, and ReLUs are not really that frequently used in autoencoders. So just kind of I said a lot of mumbo jumbo, but the whole idea is activation function actually are helping us optimize our neural networks and preventing a neural network from collapsing into a single neuron, because essentially it's just a mathematical operation that you do with your multiplications and additions. Now in this lecture, I'll just sort of after this talk, you see this quick kind of a fast GIF. I kind of draw a simple explanation to try to explain what activation functions are. I'm going to be going deeper into activation functions and going to soft plus, max out, ReLU, LU, shifted ReLU, a whole bunch of activation functions that are used. And the next couple of lectures will be going deeper into individual activation functions. So take a look into our LinkedIn group, also on our company page, and see whatever that you can make out of it. So I'm super excited. I have a pretty bad sort of a toothache, but I thought I could spend some time and sketch out some stuff for you guys. It's a great learning process. I enjoy learning myself, really. That's the most beautiful way to continue to keep focused on creating wonderful applications with machine learning and deep learning, and that helps you also constantly in your learning mode. So I hope you enjoy this, and I'll see you guys in the next class. Take care.